The derivatives of inverse functions. To illustrate the rule, let us assume we have f of x that is continuous and differentiable with f prime x as the first derivative. Now, f of x is also invertible and it has the inverse f inverse x. Then, to find the derivative of f of inverse x at x equal a, all what you have to do, you will say it is equal 1 divided by the derivative of f inverse of a of the image. Take the following example. F of x is a polynomial and we are requested to find the derivative of the inverse of this polynomial at the point 1. Now we notice that f of x is a polynomial, thus it's continuous, differentiable at the same time, and I know that it's invertible. But how to tell you that it's invertible? First of all, I will go and find f prime x, and it's easier. It is 5x to the power 4 plus 6x squared plus 7. Now, I know from my experience this is a one-to-one function, but in your case, how you will show him? If you check f of x, you'll discover it's not easy to find the inverse with your limited tools. Thus, you will build up a table and you will select random variables. Now, we go to the second page. Now, I am building up a table. I will take f of x and I will select random values like x equals 0, x equal 1, x equal negative 1, and I will replace them within f of x, and I will compare the answers. Now, if the answers are not repeating each other, or the values of y or the outcomes are not the same, it means it is one-to-one. In this case, if I select x equals 0, then f of x equal 1. X equal 1, then f of x equal 11. X equal negative 1, then f of x equal negative 9. Different values, it means for sure this is one-to-one function. It means it has an inverse. Now, I want to remind you of the rules. My question was, I wanted the derivative of f inverse x at x equal or f inverse 1. Now you go to the table, you go to the outcomes or to the f of x. You will notice that 1 happens only at one value when x equals 0. Thus, x equals 0 has a relationship with the answer. Thus, I'm just here illustrating again what I said a little bit ago. Thus, I want to find f inverse 1. I will go to the table. I will check. I will discover it's happening at x equal 0. I want you to see how I'm doing this from the table that I'm showing it in front of you. Thus, now I will discover that f inverse 1 is equal 0. I will take this 0 value and I need to replace it within the derivative, the first derivative of f of x. Now, and I will apply the rule. Thus, my answer should be 1 divided by f prime 0, and if you replace it, the answer will be 1 over 7. In the coming example, we will do the same thing but in an easier way. Now, we are requested to find the derivative of the inverse at a if a equal 2 for the current f of x. Now, first of all, I will advise you to substitute a equal 2 in place of f of x. Now, this is a long polynomial. If you don't have a graphic calculator, then you need to try by selecting random values to find which x will give you 2 upon replacing. Thus, now when we try, we discover that if x equal 1, then f of 1 will be equal to. Second step, you have to find the derivative and then replace 1. Thus, f prime at x equal 1, it is equal 4. Now, you use the rule of a derivative as illustrated in front of you, and the answer will be 1 over 4. The coming example, you're given the point 2, 3, which lies on f of x. Now, we want to find the derivative of f inverse x at x equal 3. Now, how we would do it? We will say, okay, fine. First of all, we will apply the rule. It is 1 divided by f prime f inverse a, and a equal 3 in this time. Now, we will say, okay, what is the f inverse 3? Go back to the point, it is 2. This basically you will say the answer will be 1 over f prime 2. You find f prime or the first derivative of x and you replace it by 2 and then you substitute 1 over 4 will be the final answer. That was the end of the lesson. Thank you for watching. Please do not forget to subscribe, share and like this video. Thank you.